All right, welcome back. This is 2.3 multi-stepped equations. All right, so if you missed class, this would be a great thing to do to watch this, okay? So we'll go over, it's basically the same thing we've been doing before. In our last class, right here, we have 1 and 2 step equations, all right? But this class, we're doing multi-step. So basically the same thing, but more than 2 steps, okay? All right, so multi-step equations differ from 1 and 2 steps because oftentimes they have parentheses. We have to combine like terms, and they have variables they can have variables on both sides of the equation. Okay, but anyways, you would be doing the same thing. So if you need to, go back to 2.2 notes to get a review of what we covered before. All right, so these are some things that we have to do with multi-step equations. So we have to use the distributive property. Oops, not any. Distributive property. Okay, so let's do some examples of doing the distributive property. Okay, so here we have, and we did an example of this, I think, in our last class, but here we could distribute. That would give us 2n minus 10 equals 6. Okay, and now we're down to a 2-step, so we'll add 10 to both sides. We get 2n equals 16, and then we divide both sides by 2. Okay, n equals 8. So not too bad. I just had one extra step, which would be the distributing. Okay, B, if you feel like you're comfortable doing this, just go ahead and do the problems. Okay, so here, again, we're going to be distributing. Here we have a negative. We can always put a 1 if that helps you feel more comfortable. So we can distribute that negative 1. Negative 1 times 6 gives you negative 6. And a negative 1 times a negative y gives us a positive y. Okay, negative times a negative gives us a positive. All right, so that was one step. Next step, we would add 6 to both sides. We get y equals 31. Okay, so that was really just a 2-step equation. Okay, next, again, we'll distribute negative 4r and a positive 20 equals 12. And then we'd maybe do the opposite PEMDAS, so we would add or subtract. That gives us negative 4r equals negative 8. And then we'll divide negative 4 on both sides. Positive 2. Okay, negative divided by negative gives us a positive. And then D, again, we're distributing negative 24 and negative 54D equals 30. Okay, and we'd add 24 to both sides. We get negative 54D equals 54. And we divide both sides by negative 54. And we get D equals a negative 1. Okay, so again, order of operations, like doing these things, is important. You wouldn't want to divide negative 54 first. Okay, we need to follow those steps. Okay, number 2. Another thing that we need to know is we need to combine like terms. Okay, so oftentimes we'll have combining like terms when we have separated variables. So for example, here we have 2 like terms, we need to combine them. Okay, So to finish this, it says combine like terms on the left, then on the right. Okay. So here, combine like terms, 7 minus 6 gives us m equals 20. And we're done. It says make sure you verify your answers. So to verify your answers, we would plug those back in and make sure we get the same answer. Okay, so if you did do that, you'd do 7 times 20 minus 6 times 20. Well, 7, that should be equal to 20. So 7 times 20 is 140, and 6 times 20 gives us 120. Okay, and that gives us 20 equals 20, and so we're good. Okay, all right, this one, combine like terms, so we'll do everything on one side. Make sure we keep them separate. So 6x minus 6, sorry, 6x minus x minus 2x, okay, that should give us 3x, and then we'll combine these like terms, gives us a positive 9 equals 18, and now we're back to a two-step equation. So it's subtract 9 from both sides, 3x equals 9, and then we divide both sides by 3. X equals 3. Okay? All right, next page, some more examples. So we do everything on the right side, everything on the left side. So these would be like terms. That gives us a. So 3a minus 2a gives us a, or 1a. And then these would be like terms, which would give us a negative 2. All right? Then we just add 2 to both sides. And we get a equals 7. D, again, combine like terms. We don't have any other variables, so we just combine the constants. So we'll have negative 8. 15 minus 6 gives us 9. And then 9 minus 11, maybe we should write this down separately. So 15 minus 6 minus 11. So we'll combine those two. That gives us 9 minus 11. And then we'll combine those two to give us negative 2. So we have negative 2 plus 3x. We'll add 2 to both sides. Gives us negative 6 equals 3k, and then we'll divide both sides by 3. So we get k equals negative 2. Okay, to check, we would substitute everything back in. Okay, so we'd look at that and we just 15 minus 6 minus 6 minus 11. That should be negative 8. So 15 minus 6, that would give us 9 minus 6 minus 11. And then that would give us 3 minus 11. And that would give us a negative 8. So works all great. Okay, all right, and number 3, I think that's the last one. Get the variables to one side of the equation. All right, so here as you look at this example, we have a variable on this side, we have a variable on this side. Okay, so we would want to move one to the other. Okay, since we want to have x by itself, it wouldn't be good to bring it to that side. So what we're going to do is we're going to add 5x to both sides. That way the negative 5x and the positive 5x cancel. We get 4 equals negative 3 plus 5 gives us a positive 2x. And then we'll divide both sides by 2. We'll get x equals 2. Okay. Again, we kind of can have our choice. We could add 8. Let's add 8 to both sides. Add 8j to both sides. Okay, that would cancel. Would end up getting 4j plus 10 equals negative 10. And then we could subtract 10 from both sides. We get 4j equals negative 20. And then we'll divide both sides by 4. Okay, hopefully you're not just watching. Hopefully you're giving this a shot without or before I do it. Okay. C, same thing. Okay. We can subtract 2x from both sides. Okay. If we wanted to, we can combine these. That gives us 4x. Okay, so 4x plus 1. Here, let me try this a little differently. Okay, so let's combine like terms on each side first. That will give us 4x plus 1 equals 2x plus 37. And then we'll subtract our 2x. That would cancel. You get 2x plus 1 equals 37. Okay, then we could subtract 1 from both sides. 2x equals 36. And then we'll divide both sides by 2. So x equals 18. Okay, D, same thing. So we need to have the variables on one side. So we'll subtract 2r. We'll do 7r equals negative 21. Okay, and then we'll divide both sides by 7. We got r equals negative 3. All right, so that covers all those 3 rules. Now we're just going to do some more examples, okay? So we're kind of mixing all of them together, and I think we have some special cases. All right, so let's get over some of these examples. So it says, solve each of the following multi-step equations. Make sure you verify your answer. Okay, so I would suggest always verifying your answer. So let's start by combining like terms. So we have 1x, 2x, 3x, 4x. So we have 4x, and then we'll combine our constants. 2 plus 4 is 6, plus 6 is 12, equals negative 28. And then we'll need to subtract 12 from both sides. We have 4x equals 40, negative 40. And then we'll divide both sides by 4. Okay. To verify your answer, you plug it in for your x's. Okay. B, sorry. We can distribute first. So that would give us 6a plus 4 equals, and then we'd probably want to combine like terms on the right side. So that would give us 3a minus 2. Okay, and then I think we need to have the variables on one side, so we'd maybe subtract 3a on both sides. That would give us 3a plus 4 equals negative 2. And then we'll subtract 4 from both sides. And then we'll divide 3 on both sides. So a equals negative 2. Okay, C. Yeah, there's a lot of examples. Okay, if you feel like you're good, don't waste your time, okay? All right, so same thing, we need to have variables on one side. So maybe we'll add 2/5 x on both sides. Okay, so we'd have negative 9 equals, okay, so we have 5/5 x, 3/5. 3/5 x plus 2/5 x. Well, what is 3/5 plus 2/5? Right? Well, remember you just add their numerators, so we'd end up getting 5/5 x, which is just 1. So we'd just get x equals -9. D, okay, again, we need to have variables on one side, so we could add 3x to both sides. That would cancel. We get 29 equals 8x plus 5. Then we'd subtract 5 from both sides. We'd get 24 equals 8x. And then we'll just divide both sides by 8. And we'd get x equals 3. Okay. Next, E. Again, combine like terms. These are like terms. So we'd have -2d plus 4 equals 72. Would add 4 to both sides. Get -2d equals 76. And divide both sides by -2. You get d equals a -38. Okay, may need to use your calculator to do that one. All right, decimals, same thing, so don't be afraid if it's decimals. Okay, we distribute 2 times 0.4 gives us 0.8. Okay, times 0.4 times 3. You could put that in your calculator. That gives us 1.2 equals -0.2k. And combine these like terms gives us -8. All right, we need to have variables on the same side, so maybe we'll add 0.2k to both sides. That would cancel and get 1k plus 1.2 equals -8. And then we would need to subtract 1.2 on both sides. And that ends up giving us k equals -9.2. Okay. So there are some special cases when we're solving equations, okay? So let's try and solve this example, okay? If we need to, we would need to get x on one side, so maybe we'll subtract x to both sides, okay? And when we do that, those would cancel out and we'd end up getting 3 equals 5. Well, can 3 equal 5? It can't. Okay, so let's read what's right next. Okay, it says, that can't be right. We know that 3 does not equal 5. It is a false statement to say that 3 equals 5. So we know that there can be no solution. There is no way you could plug in x equals a value and have it be actually correct. Okay, so this would be a no, there would be no solution. Okay, so let's look at another example. Let's try and solve this. Okay, well, here we would subtract 2x from both sides. We need to have them on the same side. Again, we'd end up getting, they would cancel out, and here we'd get 1 equals 1. Okay? So in this situation, it says, okay, when does 1 equal 1? Okay, all the time. So it doesn't, in this situation, you could plug in anything for x, and it would always satisfy the solution, okay? And this is called an infinite solution, infinite solutions. Okay? So there's infinite solutions, different ways different x values you could plug in that would still satisfy the equation, okay? And infinite, the symbol for infinite is like an 8 on its side. Okay. So there are 3 different types of solutions. Okay, and let's go over these. We've already been doing, I guess we already went all 3 of them, but we're just going to combine it into one thing to look at. Okay, so one solution would be, for example, this example. Okay, let's see if you can give that a shot. I'm just going to try and do something really quick. Okay, so here we would maybe subtract 2x from both sides, and we get 2x equals 6, and then we divide both sides by 2, and we get x equals 3. Okay. And then, sorry, give me 1 second. I just don't want to miss anything. Okay. Exactly. Okay. All right. Sorry about that. 2 solutions. So here we see that we have 1 solution. No solution. If we solve this, we subtract 2x minus 2x. Okay, would end up getting 10 equals 20, which is impossible for that to ever happen. So we'd have no solution. Okay, so all variables are eliminated, and you are left with a false equation. Okay, there's no way this could happen. Okay, and then we have infinite solutions. So here, kind of the same example what we did before. Subtract 1x from both sides would end up getting 7 equal to 7. Okay, all variables are eliminated. And you are left with a true equation. Okay. All right, so that covers 1 solution, no solution, and infinite solution. So on your homework, make sure you label when you're done if there is 1 solution, no solutions, or infinite solutions. All right, we'll see you later.